All right, here we go. Raise your hand, please. I don't want any blurting out. Raise your hand for questions, and then, if I ask a question, I want your hand raised to answer it. All right. Which ones we need to look at? Alidi. 16. All right, 16. Your company needs to design a cylindrical metal container or design cylindrical metal containers with a volume of 16 cubic feet. The top and bottom are made of material costing $5, and the material for the sides is $2. Find the radius, height, and cost of the least expensive container. All right, so raise your hand, please, if you got something for me on this one. What do you got, Mallory?
So volume's going to be your secondary, so it'll be like 16 equals, what is that, 2 pi r squared?
Pi
Something like that.
r squared h. So volume of a cylinder is pi r squared h.
Is it not 2?
We're doing volume. When we get to surface area, that's where there's 2. All right. So what's my primary? What is it we want to minimize or maximize? We want to minimize cost. So we want to minimize cost. So it says the top and the bottom are $5 per square foot. So that means I need to find what of the top and the bottom? Surface area. So what's the surface area of the top and bottom of a cylinder?
2 pi r squared.
Well, you're answering more than I asked for. John Ryan?
2 pi r squared.
All right, so that's for both of them combined. Is that what you're telling me? So pi r squared on the bottom, pi r squared on the top. Add those together. You get 2 of them. And those are $5. So I multiply that by 5. Okay, then the sides cost $2. So what shape, if you unravel the sides of the cylinder, raise your hand, please. If you unravel the sides of the cylinder, what shape do you have?
Rectangle.
Raise your hand, please. What do you have, Valerie?
A rectangle.
You have a rectangle. Okay. The height of the rectangle should be easy. It's just h. Okay. But raise your hand, please. What's the base? Circumference of the circle, which is, what's my formula? 2 pi r. All right. So that gives me the area of the side, and how much are the sides worth? 2. So if I clean that up, I'm looking at 10 pi r squared plus 4 pi r h. And I think you guys are telling me that this right here, what we just did, is the hardest part of these problems. You guys agree?
Yes.
Okay. From here, everybody knows what to do, correct? All right, Jennifer, what's next?
Solve for your secondary.
Okay, which one of those 2 do I want to solve for? Why? All right, give me a better answer. Rashawn?
You wouldn't have to take the square root of anything. There's only one h.
Only one h where? What I'm wanting is there's only one h in the primary. So that's our main reason why we want to get it by itself. Okay? All right, so 16 over pi r squared equals h. Abby Davis, what's next? Plug that into my primary. So that's going to be 4 pi r and then 16 over pi r squared. We clean that up. So that's going to be what, 64 and over r. So the pi's cancel, one of the r's cancel, leaves me with 64 over r. All right, Natalie, what's next?
You take the derivative.
Take the derivative, good. So I'm going to get 20 pi r, and I hope we're getting good and really efficient at taking the derivative of something that looks like that. Mallory?
Can we get like a common denominator?
You could, but I would recommend you wait until you take the derivative to get the common denominator.
64 r to the negative 1.
Say it again.
64.
You could change it to 64 r to the negative 1, but I'm wanting you to do something faster and more efficient. I want you to recognize what happens every single time. Roshan?
The top becomes negative and the bottom becomes squared.
There you go. All you have to do is change the sign and make the bottom square.
So if we did r to the negative 1, we still get...
You get the same answer.
But it's just one
But
times
this is
that.
just super quick. Now I recommend setting it equal to 0, and now is where you want to get your common denominator. which gives me that. Because I'd rather take the derivative like this than take the derivative using the quotient rule. So that's why I wait until I have my derivative. All right, we're going to set both of these equal to 0. So r equals 0 on the bottom. Does it make sense for my r to be 0 though? No. So 64 equals 20 pi r cubed. So 64 over 20 pi, and then the cube root of that is going to give me r. So what does that mean r is? 2.167. All right. So my radius, do I have units? Feet?
Yeah.
Okay. Now, make sure, because some of you didn't do this on the quiz, make sure you answer what the problem wants. What does the problem want?
The radius, height.
Radius, height, and cost. Because I'd be willing to bet that some of you didn't give me the cost and you just found the radius and the height. So make sure you answer your question. Roshan?
I got something different for radius.
You got something different?
I got 1.006. Look, I can't do that.
Anybody else? You got that one? What was it again?
1.006.
Type it in and see.
Sure.
Yeah, I reduced it by 4 before I did.
Yeah, I got radius.
What'd you get? Did you get the 2?
Well, I had it. When you plug in 3 root of 64, it's 1.0.
So the cube root of this?
Yeah.
Alright. Alright, so then I take that, plug it in there. What do we get at the height? Roshan, what'd you get?
5.032.
5.032. Now, did anybody do part number 3? Jen, what'd you get?
95.
I remember that number, so that's definitely good to go.
Would you just plug that into your first cost equation?
I would plug it in probably just right there, because then all I have to do is plug in R there and there.
Because you plug in the first one.
You could plug in, yes, you could plug in here, but then you got to plug in R and you got to plug in H.
But you have both of them.
You do have both of them. You are correct. But yes, you should get the same answer either way. All right, questions on this one before we clear it? All right, raise your hand if you got another one for me. Abby? 15. All right, management of a large store wishes to add a fenced-in rectangular storage yard of 20,000 square feet using the building as one side of the yard. Find the minimum amount of fencing that must be used to enclose the remaining 3 sides of the yard. So, I've got this building, and then I want to fence in something on that building. So here's my building. And this is going to be my fence. Okay, I'm going to go ahead and label this as X and label that as Y. So it says we need to fence in 20,000 square feet and we want the minimum amount of fencing. So somebody raise your hand and get me started on this. Abby?
Okay, so I did perimeter equals 2y plus x. But I did
Alright, I like that. 2y plus X. Everybody understand why we have 2y? Okay. Hunter, what else? Got anything else for me? You don't have anything else for me? What do you got, Abby?
I did xy equals 20,000.
XY equals 20,000. And why are you asking about this?
I just want to make sure I did it right, because he got different numbers than I did.
Okay.
Well, how do you do 2y?
Because there's a Y here and there's a Y there. I'm looking at perimeter, so there's 2 of them. All right, Zach, what's next? The problem's up here. Don't look at me. Look at the problem. Tell me what to do next. You should know what to do.
Solve for x
Where?
on the 2,000 or 20,000.
The 20,000. All right, why are you solving for X?
Because they only have one. It's not. The other one's 2 items only.
This one has a coefficient. This one doesn't. Very good. So 20,000. You can get the correct answer if you solve for Y, but myself, I'm always trying to find the easiest way to do something. All right, so P equals 2y plus 20,000 over what? Brady, what's next?
Wait.
I'm right here.
Set it equal to, or
Derivative.
derivative.
So P prime equals 2, and then what's this going to be? Negative 20,000 over y squared. There it is. Elias, what's next?
Is it equal to 0?
And what else do I want to do at the same time? Very good. Which gives me that. So set both of those equal to 0. Doesn't make any sense for y to be 0, so I set it to the top. Add the 20,000 divided by 2. I get y squared equals 10,000. And then I take the square root, which gives me 100. All right. So if y is 100, x is going to be 200. Make sure we answer the question though. What does the question say? Amount of fencing. So what's my amount of fencing going to be?
2y, so makes 200 plus 200 is 400.
So 400 feet. I need 400 feet of fencing to solve that problem.
That's just
Lee?
Why do you need 400?
Because I've got a y and a y. So that's 100 and 100, which is 2. I got a 200 there. So 200 plus 200 gives me 400.
You're finding the amount of fencing.
Amount of fencing is the perimeter, correct. All right, anything else on this one before we clear it? All right, raise your hand if you have another one. Mallory?
13.
Product of two positive numbers is 588. Minimize the sum of the first and 3 times the second. All right, raise your hand if you got one of the equations for me here.
588 equals x times y.
588 equals x times y. So the product of two positive numbers is 588. I like that. All right, Drew, give me the other one.
X plus 3y equals...
X plus 3y equals M. What is it I'm trying to find? The sum. You can use whatever variable you want. I like to, try to get as close as I can. So I went with S. All right. Maddie, what's next?
You find x
All right. Why are you solving for X?
because there's only, it doesn't have a coefficient.
Very good. So X equals 588y. We substitute that in. Gives me that. Ivan, what's next? Take the derivative, find the common denominator. So S prime, so negative 588 over y squared plus 3. Negative 588 plus 3y squared over y squared. And let's go ahead, set it equal to 0. So at the bottom equal to 0 gives me 0. Am I allowed to have 0 as solution? No, because the problem said I need what? Positive numbers. 0 is not positive. So I need the square root of 588 divided by 3. What does that give me? 14. So I plug 14 in here. What do I get for X? 42. Okay, the problem says the product, minimize the sum, and it doesn't really say what it wants. I need to rewrite that problem. So my two numbers are 14 and 42. Questions on that? Zach?
I kind of just nodded for making sure. On like MBT, that whenever you take A-Rock and say equal to the derivative, it said if you get like numbers that are outside the interval, it doesn't work, right?
You don't use those numbers. You only use the numbers that are inside the
Basically, if you have both numbers that aren't inside the interval,
then something's wrong.
it's wrong. Like,
Because if you can use the MVT, then you should get an answer.
okay.
All right, raise your hand if you have another question. Alidi?
Can you go over number 6?
6. Alright, something close to that. It says the graph of the differential function f is shown on the closed interval from -3 to 6. How many values of x in the open interval from -3 to 6 satisfy the conclusion of the mean value theorem for f on 3 to 6? Raise your hand if you know what's going on here. Alright, Hunter, what's going on?
So it's trying to say that you're trying to find where A-Rock and I-Rock are equal.
Correct.
And so you draw a secant. What I did was I drew a secant line
Perfect.
from the beginning to the end of,
So we drew our secant line.
and then I just eyed it and saw that so at the top and bottom of
So you found what?
curves were,
You found tangent
I-
lines. You found tangent lines that are parallel to this. So there's a tangent line somewhere in here. There's a tangent line somewhere in there that are parallel. So however many places you have parallel, that's going to be your answer. So our answer is 2. Good, Hunter. Everybody good with that? What else you got, Hunter?
8.
8. Thank you. All right, so function, for the function f prime equals that, f of -3 equals 2. What is the approximation for f of -2.8? Found by using the tangent line to the graph of f at x equals -3. Raise your hand if you can help me on this one. Zach?
So you find the equation of the tangent line, right?
Okay.
And so you know that your x value is -3, and so you plug -3 into the derivative to get the slope.
All right. So -27, so that's -54. That turns into 15. So what is that? 39?
And then you already have your y value, so you just make your equation. It's like y minus 2 equals, and you get -39 parentheses x plus 3. And then
Okay.
you plug in 2.8, -2.8 into x. And then you solve for that.
All right. So that's going to be 0.2. So what is that? 7.8. So that's going to be. Make sure you give me this as your final statement right here. So, not 3, not -3. Yep. Very good. Okay, one of the monster things, important things we need to be able to do in calculus is this step right here, writing the equation of a tangent line. Okay, we have got to be able to do that. Very important. One of the key things we got to do in calc. What else? Melanie?
Can you work out 10? I just want to see if I got it right.
10. Alright, so 10 gave me everything I need, so that's going to be y plus 2 equals 2/3 x minus 4. Everybody good with that tangent line? Okay, now 10 says, what would the approximation to a 0 of f be if the tangent line to the graph of f at x equals 4 is used. So
this is where we change y to 0.
this is where you put a 0 in for y.
Well, I always forget that. I put it in for x.
Now I'm going to show you something I do because you know me. I like to get rid of fractions whenever I can. So whenever I have a fraction in this situation, I always take the top number to the right and the bottom number to the left. And that automatically gets rid of my fraction. That way I don't have to deal with it. So we get x equals 7. Now raise your hand, please. Very important. That way we understand what's going on. What's going on, or what are we saying is going on at this spot right here? Raise your hand. Don't blurt it out. Mallory?
That's where, like, it's closest to 0 or something, or like it's 0.
You're close. Give me something.
Like the tangent line or something's like 0.
No. What do you got, Zach? No. Roshan?
Using that tangent line at 7, like, using this tangent line with y is 0, and you're trying to find where y is 0 on the tangent line.
So what's an easy way of to say what's happening at x equals 7? Right, but what's happening if you have a y value of 0? What's your graph doing?
Across 0.
Thank you. Everybody hear Ivan? Ivan, what'd you say? I'm touching the x-axis. Okay? So what we're doing on this problem right here, they're asking you to use this information to estimate when the function is doing what? Touching the x-axis. Okay? I want to make sure we understand that's what we're doing when we do this problem. Okay? We're estimating that that function, with the information they give me, is touching the x-axis at 7. That's what's going on. Okay? I want to make sure we understand that problem. All right, what else? Raise your hand, please. Girl? 7. Seven's a jacked up problem, by the way. I need to rewrite it. So I need to rewrite it and change some of the values in the table. Like if I rewrite it, here's what I'm going to do next time. What I'll do next time is maybe say 0.8 or 0.6. 0.65, 1, and 0.5. So I'll do that next time. And so they said at t equals 0 we have 104 gigaliters, and t equals 30 we have 125 gigaliters. So twice differentiable function w. When you hear twice differentiable, what do you automatically should think of? MVT. Whenever you hear twice differentiable, you should think I can use MVT if I need to. Okay, what else can I use if I need to? I can use IVT as well. Okay. So it wants to know, is there a time where W prime of t equals 0.7 gigaliters a day? Okay, so what does W prime of t represent? IROC. So if they're asking about an IROC, what do I need to find? I need to find an AROC. Okay, so what you've got to decide on this problem is, am I going to do AROC with W prime of t, or am I going to do AROC with W of t? So somebody raise your hand and tell me which one I want to use and tell me why. Hunter, what do you got?
You use W prime t, right?
You're going to use W prime of t. Why?
Because you don't have WT, and whenever you plug in with AROC, it'd be W prime.
I do have this right here and this right here. Those two are W values. So I technically do have W.
I don't know.
Ed, what do you got? Which one and
We
why?
use WT.
Say it again.
We use WT.
You use WT. Tell me why.
Well, you're finding the rate of change. So whatever, when you use the formula W of V minus W of A over V minus A, you're going to get W prime T, which is your arrow.
All right, you're close to what I'm wanting. He's right around what I'm wanting. What is he trying to say?
Is it because the units?
There you go.
Because
That's
you
what I
have
want to hear.
gallons per day squared.
Right, because if I use W prime of T, I'm going to have gallons per day over day, and the units for what they want me to get are what? Gallons per day. So that means I need to have gallons on the top, and I need to have days on the bottom, so that means I need to use whichever one of these has gallons in it. So which one has gallons? W does. And these are my gallons right here. Okay, that's what I want. That's why I did this problem, even though I didn't write it very well. I wanted you to struggle and decide which one of these do I need to use. That was the purpose of this problem. Okay? So when I do that, I get 125 minus 104 over 30 minus 0, so that is 21 over 30, and that gives me the 0.7. So then you can just say yes, MVT. Okay, so that was the main purpose of this problem, is for you to struggle and figure out how you need to use which one of these. Okay, so I wanted this to kind of be a decoy. And I wanted you to know, I wanted you to say, Coach White is always emphasizing your best friend is your units. So let me check my units, because my units tell me what to do on this problem. Make sense? Even though it wasn't written very well. That was the purpose of it. Now, let's go back and talk about something else, because it's always good to talk about it, because it's something my calc kids always struggle with. And that is what are these two, and what's the difference between the two? So could somebody tell me, raise your hand, and at least tell me what one of them is, and get me going?
Like what the letters stand for?
No, what's going on? I want you, Devil. What do you got?
MVT is whenever there's a twice differential function that where AROC and IROC are equal.
AROC and IROC are equal. So you're guaranteeing that IROC is equal to AROC somewhere on an interval. That's what's going on at MVT. Okay? All right, Leilani. Do this one, because this is the one we always struggle with. What's IVT?
So you're given an interval and a number, and you want to prove that that number is in the interval somewhere?
What kind of number?
Wait, X value?
No. Y value.
Oh.
Okay? We're wanting an X value that produces a Y value.
Yeah.
So if I have a Y value of 20, and I've got a Y value of 15, then I can always prove that any of these Y values in between here must exist. That's the IVT. Okay? If you've got some Y values and you want to prove that something in the middle has to exist, that's IVT. Okay? MVT, we're pretty much going to prove it that what exists. We're wanting to prove a Y value exists. On this one, what are we wanting to prove exists? What type of rate of change? The other one. Instantaneous. Here, we're wanting to prove an IROC. Most of the time when this shows up on the calculus, we're wanting to prove an IROC exists. Okay, on this one, we're wanting to prove a what? A Y value. Okay, so usually what they ask you, you'll be able to say, all right, they're wanting me to prove an IROC exists, so that means I need to show MVT. Or they're just wanting me to know does a Y value exist, that means I need to use IVT. Okay, write these down for me real quick. MVT, we're going to prove an IROC exists. IVT, we're going to prove a Y value exists. That's good stuff. That's your bonus piece of information today. No charge for that one.
Wow, thank you so much.
Well, because what do you not need for IVT? You don't need the derivative, so that means you can learn this one before you learn this one. But I kind of like where you're going, where you're thinking there.
Because so that way you know what to be next.
Right. It's going to be on the video. But I like what you're thinking, Mallory. I may change that up.
So it's fine.
Wait, did we learn IVT this year or was that last year?
This year. I mean, in the fall. Okay, but you
Did
can.
we know how to take the derivative in the fall? Did we not?
We didn't until like halfway through. Okay, but I like what you're thinking there. Because by themselves, when you're dealing with one or the other by themselves, they're not that difficult. When you have to decide which one you need, that's when they're difficult. So it might not be bad to learn them at the same time. That way you can tell the difference.
Just do like derivative first and then go into that.
That's good. All right, what else you got?
I should just be a teacher already. So what did you get for 12?
I don't have my answers on me. If somebody will show me what you got, I might be able to tell you. Yeah, that's it. 0.38 miles per whatever squared, miles per minute squared. You have your calculator on you?
Yeah.
All right, what else? You got anything else? What else? Let's go through these types and tell me how you feel. Give me a 1 to 5. 1 and 2, where you're just figuring out average rate of change. How do you guys feel? Show me. All right. Then we get into 3 to 5, which is applying the MVT. How do you guys feel? Okay. What do you need to make sure you do on 3 to 5? Check to see if you can use it, because a lot of people will do all the work and you can't use it. So make sure you check to see if you can use it.
So how do you, I know it's differential continuous. So say you have the first one, the cube root of x minus 1. So what would make that not work would be like -1. No, it would be like 1.
There is nothing that will make that one not
Or
work.
I'm thinking of negative
Yeah, even radical.
Maybe
Even radical. You're looking for an even. What are the things you're looking for on continuity? Even radical, fraction, piecewise. All right, if you don't have any of those, you're guaranteed for it to be continuous. Okay, then how do you tell if something's differentiable? You ask the same questions about the derivative. That's how you tell whether or not you're continuous and differential. So you're asking the same questions. You're just asking it about the two different
You
functions.
can find your A-rock and not really find your I-rock.
Correct. You can always find an A-rock. All right. So that's that. And then we have 6. How do you feel about it? Looking at a graph, figuring out how many I-rocks there are. How do you guys feel? Okay. All right. Then using a table to approximate I-rocks. Using a table to approximate I-rocks. What do you use? What do you use to approximate I-rocks? A-rock. All right. Then we've got our tangent line approximations. How do you feel about those? All right. Then we got the good stuff. Well, there's some more approximations. Then we've got 13 to 16 optimization. How do you guys feel about optimization?
2.5.
2.5, 3.
This depends on the problem.
Two videos are like points.
Yeah.
Points.
Yeah, we're
15 is easy.
Like 14?
Yeah, like I think.
All right, talk to me about 13 and 14. How do you feel about 13 and 14? You don't have 14? We ain't looking at 14? Is that what you're telling me? All right. What about something on the distance?
Yeah, and so like, then you just take the, does it matter
When you go to take the derivative, that's when the radical goes away.
Yeah, I get confused on the distance one.
Okay, we'll do that one. We'll do that one next. So we'll knock that out. All right. So we'll do distance, and then we'll finish up, and then I'll do the rest of them online.
Are you going to give us any formulas on the test or no?
Well, if it's any type of box, I'm not going to give it to you. If it's a cylinder, I'm not going to give it to you.
I don't know this one.
I'll give it to you on a cone. I'll give you a cone, but I'm not going to give you a cylinder or a box. We do those too many times. So if you don't know them, learn them.
This is just the x2 minus x1 squared plus or minus?
Plus.
Plus y2.
Alright. So x2 minus x1 squared plus y2 minus y1. I don't know why I put it there. Squared.
So anytime it asks for points, you do the distance. Or
Well, if it wants to know closest, if it says closest, that's a distance. We want it close. Anybody tell me where the distance formula comes from? Do you recognize this? Ivan, what is it? It's nothing more than Pythagorean theorem. Because what happens when I square both sides?
what the heck?
Does that look familiar?
Yeah.
Something squared equals something squared plus something else squared. Distance, or Pythagorean theorem. That's all the distance formula is.
So can you do like the Pythagorean theorem and so much?
Well, you're finding a distance, so you're just solving for it. Alright, so in this case, our point is 3, 0. So x minus 3 squared plus y squared. Okay, and then they told me y is the square root of x plus 1, so we plug that in. I'm going to go ahead and multiply that out. So that's going to be 6x plus 9, and then plus x plus 1. And then clean that up. So that's x squared minus 5x plus 10. Okay, so now I've reached the point where I want to do what next? Derivative. So when you find the derivative on a distance formula problem, this is the point where you can drop the square root. So it'd be 2x minus 5, set it equal to 0. I get x equals 5 halves. Now make sure you answer the question. It says point, so what else do I need? I need a y value, so where do I plug this in?
Back at the primary.
Back in the secondary. So what was it, x plus 1? So we need 7 halves. So my ordered pair would be 5 halves, 7 halves. Now raise your hand, please. What's special about this point? Raise your hand. What's special about this point?
If the point is closest to the point. Oh, sorry. I'll probably still get it wrong.
That
It's the point that the x value is closest to the point 3, 0.
I need a little bit more. Where is that x value located? Where is this point located? Haley?
It's the point closest to the point that's on that graph, on the graph.
All right, say that again. Clean it up though. Say it a little bit differently, because you know what you're talking about. You're just not saying it right.
It's the point on that function that's closest to the point they gave us.
There you go. Very good. So this is the point. What type of function are we dealing with square root of x plus 1? What does that look like? It's that half parabola, and since it's x plus 1 on the inside, how did that move? It moved to the left, so it looks like this. What was the point they gave me? 3, 0? Okay, so there's my point. So 5 over 2 is the same thing as 2.5, so that means this point right here, that distance, if I pick any other point on this graph, it will be further than that distance. Okay, that's what it is we're finding. Okay, so make sure it's huge in calculus. Make sure you know what it is you're actually finding. If you know that, then that's going to help you down the road. Okay, the deeper you understand what you're doing, the better off you're going to be. Abby?
Do you care on the test like if we did that on my wild card, I put it in decimal form, but my actual
That's fine.
it doesn't matter.
That's fine. Remember, if you're going to give me a decimal, how many decimals you giving me? 3. You got to give me 3. All right, I will, whatever questions we didn't answer in here, I'll answer those online. Post that video, post the answers. Test is going to be Monday.
And make sure you tell us to subscribe, Coach White.
Comment up here.